going to do optimization. So I'm hoping everyone's here for this. You ready? Class.
Yes.
Thank you. Thank you. Faye. I can almost hear you.
Yeah.
Thank you. Vincent. Okay. Anyway, Nephi. At least give me a buddy Jesus, so I know that you're okay. Anyway, optimization. These are actually it. If you like calculus, these are fun problems. But you have to like calculus. Steps for solving optimization problems. Read the problem until you understand and you can identify the quantity for which a maximum or minimum value is being found. Assign a symbol to represent it. So, read it through. You're going to be making some shape out of it. So that's what it's trying to say. Minimum, maximum. And if you think about it, this is, if you were going to get a business degree, you would have to take business calculus. Okay? There is like almost everything of this. Where maximum and minimum, you want to minimize cost of your business making something, right? You want to maximize profits of your business still making that same thing. So you're going to have different equations using the same variables. That's referring to the same thing, but you want to maximize profits, minimize cost. Because if you have a business and, let's say for instance you're selling hamburgers. If it costs you $5 to make a hamburger and sell it, don't you think you need to sell it for more than $5? Yep. So to be able to do that, you would have to be able to figure out how to maximize your profits, minimize your cost. And that's where a lot of this comes into play. Assign symbols to represent other variables in the problem. If possible, draw a picture and label it. Determine relationship among the variables. Express the quantity to be maximized or minimized as a function of the other variable. Determine a meaningful domain for the function. Find the absolute maximum value or absolute minimum value of the function. Okay. These are going to be item by item, step by step. Farmer with 4,000 meters of fencing wants to enclose a rectangular plot that borders a straight river. If the farmer does not fence the side along the river, what is the largest rectangular area that can be enclosed? Okay, so now let's go through what is it my end goal? My area, right? I need to maximize my area. Okay? So, in sense of calculus, if I'm maximizing the area, I know what about that? What do I know about the maximum area? Just use what we learned in calculus for this. What's the whole idea of the calculus? What we were talking about earlier. Derivative equals 0, right? I'm going to have the derivative equal to 0. So I need to maximize the area. Set the derivative equals 0, and that's what we get. So now we're going to have area. So I have the area formula and the area of that shape. How would I find the area of the shape? X what? Area. Times what? Base times height. Length times width. So there's my area. And what are we going to do with this? We're gonna put what around it? We're gonna put a fence around it, right? Okay. So I'm going to use that to actually help maximize this. So all I have is 400 meters of fencing. So with that 400 meters of fencing, or I'm sorry, 4,000 meters, I know that my sides must include this one here, that's 1x, plus y, plus x. Those three things together. So, and if it was all four, it would be x plus y plus x plus another y, right? If I was going to enclose it all the way around. But I only need three sides. So together, I'm going to have 2x plus y. So this right here is what I'm going to use to try and substitute in for my area. So if I'm doing the area, I don't want to have two different variables. I can do two different variables. I don't want to do two different variables. I want to only have one variable. And the easiest variable would be isolate my y, right? So subtract 2x from both sides. I would have 4,000 minus 2x equals y. So now I'm going to substitute my y value for all of this. I'm going to go to another page for this so I have a, and I'm replacing the y with 4,000 minus 2x. So 4,000 minus 2x, I'm replacing that. There we go. So now I only have one variable here, so now I'm going to distribute to make my math a little bit easier. A equals 4,000 x minus 2x squared. And at the beginning we said our goal is to maximize the area. So I'm going to find the derivative, set it equals 0. So as I do that, that's going to be the derivative of a dx. So in terms of x, this is going to give me 4,000 minus 4x. Say, wait, did I make a mistake? What's wrong?
Didn't you say 4,000 equals 2x times y?
Yes, but I isolated y right here, right? I subtracted 2x from both sides. So 4,000. Sorry, I didn't show that step right there.
Wait, why is it going from multiplication to division?
Because we have 4,000 meters, so that's like the perimeter.
Yeah, this is the whole thing right here.
Oh,
So this right here is my area. So this is area, but this one over here is my perimeter. Help me out, P-E-R. And I know, right? Well, that part of the board's dead, so it doesn't want to actually write. Anyway, so perimeter. So we have two different formulas, so I'm substituting my perimeter into my area because I have to combine both the equations into one somehow to actually maximize it. Does that help? Vincent, is that what you were saying? Okay. Alright, so now we have the derivative here. And we need to set it equal to? Set it equal to?
0.
0. You zoned out for a second, did you? I got you though. Okay, we're back. So set it equal to 0. And every time I do this, Christian, you say this all the time in your head. You look at that problem, you say what?
Oh, F that.
F that, right? So we're gonna F that, take out a 4. I'm left with 1,000 minus X. The 4 is gonna go away. I'm gonna be left with X equals 1,000. Let me back it up a little bit. Hold on. Okay, so right here, this is gonna 4 does not equal 0, so that's gonna cancel out, right? So I get 1,000 minus X equals 0 plus X. X equals 1,000. There we go. Sorry, brain hurty today. I'm not really. I wish I could be. Trying, so I'm skipping the steps. Apologize. So what does that tell me? What does that tell me now? Yes, the side is now 1,000, right? Let's go back to the problem. So this is 1,000. This over here is also, and I could plug in over here. I could plug in over here if I know X is 1,000. 2 times 1,000 is 2,000. 4,000 minus 2,000 is going to give me my Y, which is 2,000. Or, I just know it all adds up to 4,000, so that's a missing segment, right? Okay. Now, let's go back to what it's asking for. The farmer does not fence inside along the river. What is the largest rectangular area? So did we answer the question yet? No. I got the measurements. I need to find the largest area with this now. So I know the area is going to be 1,000 times 2,000, right? So that's going to be like 6 zeros. And meters. Yes, meter squared. Is that what you said?
Yeah, that doesn't matter that much.
It doesn't matter?
Well, but I'm just, I just didn't see if you put it or not.
Oh, yeah. Yes, it is meter squared because it's area. Alright. Questions, concerns, conspiracy theories? No? Okay, so we got that. Alright. Another one. This is probably the one that you're going to see the most. You're going to see this one the most out of any of them. From each corner of a square piece sheet metal, 18 centimeter on a side, remove a small square and turn up the edges to form an open box. What will the dimensions of the box be with the largest volume? Okay, so start by drawing a square. Okay, so there's my square. Now, in my square, I'm going to cut a little corner, a square out of each corner. So watch this. I'm going to dotted line through here. give it some values. If this is a square, the bottom would be x, going up and down would be my y, and now the little piece that I'm cutting off, if it's going to be a square, I'm going to call this one z, and you'll see why here in a moment. So this piece would be cut out, and when I cut it out, it's actually going to fold up. I had a piece of paper here I was going to use. Ah, here it is. Okay. So for those people following along at home, I am folding a piece of paper along the dotted lines, just like I did. So now the piece that I'm cutting out is this corner piece. So when I fold this up, I now have a two-dimensional object, the 2D, into now a 3D object. Okay, do you guys get the picture here? It's now going to be a volume off of this. So that's that little piece in the corner that I'm cutting off. Because a volume is length times width times height. In my problem here, it's x times y times z. Yes? But since we're cutting away a little bit each time, I know that my volume would equal x times y times z. Because when I fold this up, this piece right here, z, is how much it's actually going up, right? Yeah? Okay, good. Now, they say it's a square. So is y really a separate variable? If it's a square, that means that both sides, or all four sides, are the same length, right? That's important to read. If it's a square, I can replace y with just x, because it isn't a separate side, because when I do this being a square, the definition of square that all four sides are the same. Each corner of a square piece of sheet metal, 18 centimeters on a side. Okay, so now that from here, now for the sake of argument, shouldn't the maximum be without cutting out anything? Yeah? Okay, let's if I'm looking at it and I'm not zoning out, okay, it would be 18 times 18s, but what's a z? How much are we folding up? That would be 0. Because we didn't cut anything away, that's going to be 0. So the maximum volume is 0. That doesn't work, does it? Okay, so that means that we have to cut something away to be able to get a volume on this. And I gave this a z value. So I know that the whole thing is going to be 18, but I'm going to cut away z. And since this is a square, all these z's are the same. So what would I say for for my x value going here? What would be the whole thing? 18 minus 2z, because I'm cutting off 2z's, right? So down here on the bottom, I should have 18 minus 2z. And that's going to be the length there and the length there. So if it's the same thing, isn't that squared?
Oh, what did you say?
Yep. And now from there, what is the height going to be? What's the height going to be? So as I fold this up, it comes out to be,
Oh, you mean the height of the folder box or the?
yes, the height of the folded box.
Oh.
It's just going to be z, right? So with this little piece, whatever I cut away there, it gets folded up that amount, right? It gets folded up that amount right there. So that's going to be my z, is my height. So now I have made this all in terms of z by doing that. So I have my volume. Z times 18 minus 2z squared. And from what we learned in the last one, we're trying to minimize or maximize, right? Minimize or maximize, that means that I need to set it equal to 0. I need to set the derivative equal to 0. So let's do that next part. So I'm going to go to a new page here. So we could either expand this or do product rule. So I'm going to do product rule. I'm going to do product rule. So this is my F and this is my G. So F prime is going to be 1. G prime is going to be, there's a chain rule there. So it's 2 quantity of derivative right here, 18 minus 2z to the first power times the derivative of the inside is going to be negative 2. Now I'm plugging into my product rule. It's going to be F prime G F prime, so 1 times product, so it's plus G prime F, so it's going to be Z times negative 4 quantity of 18 minus 2Z. So bring it down, dV dz, and that's going to be 18 and what's that going to be? So it's minus 4z parentheses 18 minus 2z, and I can keep distributing also, so that's going to be factor out, set it equal to 0. They both have the same common factor, 18 minus 2z. And when I factor that out, I'm left with 18 minus 2z minus 4z. And that's going to be 18 minus 6z. Set each one equal to 0. And this is going to be z equals 9 for that first one. And z equals 3 for this one. Now this one right here, since I have two answers, I have to think about it with restrictions on my domain. So it could be either 9 or 3. Let's go back to the picture. So can z be 9? Why can it not be 9? You're gonna cut off the whole thing, right? So if this is 9 and 9, you basically just cut off everything, right? So that is a restriction on my domain right there. So 9 cannot work. Now 3. If I do 3, this would be 3, 3, okay, and that means that since I cut those off in between, it's going to be, how much is left in the middle? 12. What are the dimensions of the box with the largest volume? Let's go back to my information. I'm trying to make a box, so this box so from here, this one's going to be 12. This is also 12, and it is 3 high. So my volume is going to be 12 times 12 times 3. But this question is asking for what are the dimensions of the box with the largest volume. Does it say what is the largest volume? No, but it could say that though. It could say that. But right now, it's only asking for the dimensions. So my dimensions here, 12 by 12 by 3. Is that crazy? It's not too bad, right? Vincent? Okay with that one or no? Faye? Alright, I'm going to leave off here. I'm going to give you guys time to start working on these problems. Got about 10 minutes. Make sure you like, share, and subscribe.